So I had a problem there, which was something that I was thinking about before. But I was thinking that I could think about this later. But it's basically when you have a parent that isn't a part of the tree and a child, then you can have problems there. And also because of the way that I was reassigning the child in case it already exists on the tree. ChatGPT gave me an answer, but I'm not really sure if it is correct or not. But it said basically that whenever you assign a pointer instead of another instead of a function, and through another pointer that it gets created inside of that function, it doesn't really do the reassignment. And I think this is the issue that I was getting there, because on the function that I created to add the nodes to the thing based on the name, just this one here, it is important that I'm able to change the value of this pointer here so that I reassign it to point to the same node that is already part of the tree. Because if I don't, then outside of this function, after this function is called, there might be situations where the child is going to become the parents, and that's very common. So on the next time that this gets called, even if the function works correctly, the node's going to be inserted in the wrong node because the parent's not part of the tree, because it was the one from the previous iteration that didn't get added to the tree. And on top of that, there is also, like, it does feel kind of annoying to write down the whole singleton thing every time you want to add a node, and to also remember that you have to add the node after you change the state of the node, because the function depends on the state. So what got me into this problem in the first place is that I was trying to add, I got another problem that I don't remember exactly what it was. I think, yeah, the name of the pop-up menu. So the issue that I had was that the way that the editor node says the name of the pop-up menus that it has is just basically by setting the name of the node. But in my case, I want to avoid doing that because the name of the node is going to encode the differentiation. And also, I don't like it very much because let's say we want to have two different pop-ups that have the same name. Then you can't really do that because in Godot, as far as I understand, you can have two different nodes that have the same name. So I was trying to find a way to change what the display, the display text on the pop-up menu without changing the node's name. And then I realized that there was another problem because of the way that they do things there. They set the tooltip of one of the control nodes, and the way that they are able to do that is based on the logic. So you have to add the pop-up menu as a child of the main menu, so you're able to set its tooltip later based on the index because of the way that they designed the logic of the main menu. And because I was adding with my code there, it didn't have the same effect. Because also when I added to the function here, if the node is already part of the tree, then it's going to be different than using add child because it's also not going to emit events and do other stuff. So one option that I had was to put whatever extra logic that I have instead of this function here. The other logic that I was contemplating is which also ChatGPT suggested, to make this a double pointer and then dereference that way, because ChatGPT said that if you do that, it will work. Then you need to reassign like this, because you dereference the pointer one time, and that would make it work even if you create a pointer inside of the function. The other one that I was thinking about is for the parent here, because this problem was related to parent nodes. And I was thinking about just sending the name of the parent's name instead of the node, and then finding the parents on the tree instead of adding from the node outside, because then that makes it easier because you're not dealing with the pointers. But now I'm trying to go with a different approach, which was similar to what I was thinking about before, but I didn't do this approach because I thought it was kind of pointless because they are roughly the same thing. But the other approach that I'm thinking about now is that you, instead of getting the roots of the thing and then adding the nodes as you call the function that's going to change the project, which was this function in this case. So this function receives the roots of the thing, and then I was thinking about changing the root of the thing, the node that is the root of the thing, inside of this function, and then later on it's going to save this root, and that's going to change the state. But another approach you have is you create a separate tree completely independent of the thing root, and then at the end you merge the states of the tree that you created through code and the thing root. And I think that's much better because one, it makes it more it makes it be in the same way, like all the components are going to work in the same way because I'm creating the tree in the same way that I would if I wasn't caching. And also it facilitates adding the child here in the same order, so it's basically easier to build the tree. But the downside of this is that, like, because I was thinking there are going to be nodes that are created through the editor, and those nodes are going to be kind of hard. But the way that I'm thinking about now is that it doesn't really matter how many nodes you create, how many trees you create to update the main scene, because all you need to do is to make the logic dependent on an entry point node from the scene. So what I can do is like search for whatever node I want to change on the scene based on its name, and then append, put the logic like if this node exists on the scene root, then I create some function that's going to create a tree structure and is going to append the information on that node. So it allows me to, and then because I'm doing this, I'm creating the possibility to add several different roots to the scene. I'm trying to make as a vector. I still didn't test anything, obviously, so I'm going to try to develop this now. But it's basically this structure here. So each sync path is going to have a vector of nodes, and at the end of the functions. So basically, the logic to change the functional, to change the state of the scene happens for each project on the main function still, which is the entry point function, this function here. And now I'm getting both these structures here because I'm going to loop over this one because this one is also going to contain the sync path. So they're both linked through the sync path. The key is the same for both of them. But one of them contains the root of the sync, and the other one contains the vector of nodes that are going to serve as an update to the sync. So I'm looping over this one. Then I get the sync root based on the key. If it doesn't exist, I continue, print warning message, because obviously it's required to have the root of the sync. And then here I basically pattern match with the sync path and then for each sync I put an entry point inside of this path here. And then here, and then I created this other function here to make it easier. But here I think it depends on the situation, so there isn't a way to create like a generic approach because it's going to depend on what you're going to do. But basically, I can put several different functions here, and then each function is going to create its own subtree, or is going to create this state from the roots of the thing. And then after I create the node, I just append to the vector that represents the updated nodes for that sync. So I pass the sync path and I pass the roots that I just created, which is a subtree. And I do all the logic based on the names. And also on the other function, I still need the sync tree because if I have situations where I want to change the state from an existing state, I can get the name of the. And this is the part that I'm not 100% sure, but I think there's a function there that is called duplicate on the node class or on the object class. I think it's on the node class. That I think that what it does is allows you to copy the node. So that's what I'm trying to. That's the thing that I'm not 100% sure because the most annoying thing is this relationship between pointers. But essentially, I'm still passing the scene root here because it's going to serve as a search space. So if I want to if I want to create the tree and append it or add to the sing roots, then I don't do anything with the roots that I pass here. And obviously, then it's going to depend on what kind of functions I have here as well, because you can create several different functions. And then the logic is basically, the conceptual level is you use the sing root to search the path, to get the node that is going to be the entry point. And then you do the logic based, so you copy that node, for example, and then you do the logic from that node. And then at the end of the, after you create all these updated nodes, there's a function on the HD manager that is going to traverse the updated nodes, and it's going to match, it's going to search again for the main sing, for the main tree on the sing. So it's going to traverse the updated nodes, and it's going to search on the main scene if the node exists or not, and then it's basically the same logic that I was doing before. And then what I realized is that I don't need to cache the names as well on the asset, because I can always search for them on the scene, which is kind of better as well, I think, because then it makes sure that they're going to exist. And if they don't exist and I don't get the pointer, then I just don't add the subtree, and I print a warning message. So the biggest challenges, I think, and the things that I'm not 100% sure about, is whether or not you can duplicate the node. And if you can't duplicate, then it's going to be, I think it's just one extra step, because then what I'm going to have to do is just figure out how to get the state from the node that already exists on the tree, and then allocate memory for a new node that has the same state. Because the logic is very similar, the way that I'm doing there now. So here it receives the roots of the updated, and then the sync path, and then I check to see if the sync path exists on this hash here, and I'm creating the hashes the exact same way that I create the project roots, but I just initialize with an empty vector. Then here I just push whenever I want the thing. And the other function that I'm not 100% sure about is this one, I think. Is this one that I'm gonna call at the end. So I should probably put there. So before I save the, I think it's on the, yeah, it's on the headless here. And so before I do this, I just call this other one to update everything. And what this function does is just it loops over all the roots, the updated roots, like I said. For each one is from the other hash. And here I'm checking. I guess I can change this so that it checks in the same way there. And maybe that's, I think that's probably better. So it's project sans probably. Project sans. Oh, let me think what's. Yeah, so I'm gonna do it the same way that I was doing there. Because if it doesn't have a root, then it doesn't make sense to call the other function with no pointer. There's a whole point of the other one is to add. So I'm just gonna do like this, and here I'm going to this is a function from the hash map that they have on Godot. That allows you to see if the hash map has a key or not, and the root.key is the sync path. So if this is true, then it means that it has, so if it is false, it doesn't have the sync, it means I should just continue. If it does have the sync, then I get the root node for the sync, and then I loop over all the nodes that exist on the updated vector, which are based on the root value here. So the root value is the vector of nodes. So each one is going to be a node. So like each root node here is a subtree that I'm adding on the root of the scene with this function here. And this function is going to be a recursive function. So this is another thing that I'm that I also confirmed with ChatGPT, and it makes sense. But in case I want to be conservative, I can see how to explicitly say this. But it's basically the parent node here. So I'm banking on the fact that the roots, the root nodes of trees on Godot are gonna have a null pointer as a parent. So this makes sure that if it is the roots, then I can do other logic here. This is something that I was thinking about before. So maybe if I put out, this is what I was gonna do. So if the parent exists, then it means that the node is not the root. If the parent doesn't exist, then it means that the node is the root. So I have to add directly on the sing root. Yeah, but this is the thing. So I guess this depends on the logic. So maybe I should. Yeah, so here I think I could. So there's two different ways, obviously. One is to change this function so that I pass another name here, or I pass another node. And then based on the node, that's going to allow me to define at what points in the sing tree should the roots of the subtree be added on. And then I have to basically do the same logic. So maybe I should separate this into another function as well. Which essentially, like the core essence of the thing is, if the node exists on the tree already, then you just update its state by comparing the both nodes' properties. And if it doesn't, then you add to the entry point. So this was a problem on the other one as well, because the first node doesn't have a name because it's the root node. So when you want to append the child directly to the parents on the other function, I was getting an error after I changed some things here, because the parent doesn't have a name, so you can't really find the. If the parent is the sing root, then it is not going to have a name, so you can't find the nodes by searching the sing root with the find child. So let me think of this. So obviously the easiest way to do it would be like this. So you just normally add the node as a child. Updates node. So this would be the case if it doesn't have a parent, it's the root of the subtree that I want to use to update the main sing. So I just add, but I check first. So I do the same logic that I did on the other one here. So here, if it does have, you get the parents, because then it's a child of the subtree. You get the parent's name, because I already have the parent node outside. If the parent name is an empty string, I should probably continue here or something like that. I was thinking about returning or something, but it doesn't matter that much because I'm checking here as well. So the only thing that happens if you pass an empty string to the find child is that they're going to throw an error message. So I think that's why I left with this, because it doesn't matter that much. Because all the nodes should have name. And maybe this is not very good, actually. Yeah, so I have to incorporate the function there before. Yeah, I guess this is what I was gonna do. So like, because the problem here is that obviously the thing is not gonna have the name. So this is the reason why I was using the other one, I think. So I was increasing the name based on the global variable there. But what I can do is just increase at the end there. So on this one, I just set all the names based on the hash set. So instead of calling the function there to add the nodes, I just set all the names for the nodes. But is that Good. I guess this is the reason why I did. So maybe I can call the other function still, or just change the other function, because the other function already has the logic to basically increment the name and to check to see if the node has already. I was thinking I could avoid using the other one. So like the first thought that I had was to change the other one to either I was gonna do 2 pointers on the node or to change the parent name to a string name. But then I wanted to avoid doing this because it's kind of annoying, and I think it increases the risks of making a mistake. So this is the reason why I think this approach is better, because it simplifies a lot to, because essentially when I'm creating the tree from here, I want to concern myself with those things the least possible. Like I don't want to be concerned with whether or not I added the nodes in the correct way, and also to, like there might be other situations where it's gonna change the behavior of the nodes depending on if you're using add child or not and stuff like that. So it just makes it a lot easier to think about the construction of the subtrees. And I can leave all the logic, the other like problematic stuff to one place, which happens at the end there. So it's basically gonna be only one function. But now I'm realizing here, because like the issue is that these ones are not gonna have the names, because this is gonna be created normally without anything. So like one possible approach that I don't think is very good is that I just create another function to traverse the tree and then set the names of each one. But I don't think it's very good, because then you're like doing computation that is not necessary, I think. So it makes a lot more sense to. So these ones, and maybe this one I need to do inside. So this one I would do inside here as well. So instead, I think the only thing that I'm going to do differently here is just use the other function that I have there and just change the other function so that it works. But the way that I was thinking about here basically is that you get the 2 names, the name of the node and the name of the parent, which essentially is the only thing that matters to add the node to the tree. Then you find the nodes based on their names on the main sing roots, which are the nodes here. And then based on whether or not they exist, then you place the logic to either update the node or add a node to the tree. So if the parent doesn't exist on the node, then I think there is something wrong, but which is the situation that I had there before. It's like when you both don't have the parents and the child. I think it should always be the case you have the parents on the tree. But this is directly correlated with this, which is the first node you add and how you decide to add the nodes. That's the problem. Because it might be possible to have a situation where it comes down to how I want to structure the tree, the creation of the subtree, which I think it makes it a lot easier to not think about the main scene tree at all, and to just compartmentalize and just think about the subtrees when you're creating from code, and then just use the scene roots in case you want to append to. Yeah, but if you want to do that, then I think you need to, the root of the subtrees have to be a node that is inserted on the scene tree. Yeah, I think that makes more sense. So I think I should always design with this in mind. So the subtrees are always, subtrees always have, yeah, but and this is kind of the thing that is annoying, because I'm not really sure. But if I pass the sing root there and I create the subtree from the sing root, then what happens with the pointers along the execution? Because there's several different functions running. So this is the thing that is kind of annoying. So if I can duplicate, then it becomes a lot easier, because then it's a lot easier to think about. You just get the pointer for the nodes. So the logic, get the sing roots, then find endpoints, which is going to be whatever, it's going to be based on where you want the subtree to be added. Then after you find a node on the scene root, then you duplicate that node, and you're basically making a copy true. So don't worry about the pointers. Because otherwise you run into the same. But even if it's technically the same to do the two approaches, I still think it's better to update at the end, because you don't have to keep writing the long ass thing you have to write to add with this one. And also there's less chance you're gonna, because of the states there, you're gonna make a mistake. So it comes down to the pointer, I think. I think that this is the part that is confusing. So there's two approaches. Oh, what I was gonna say before is that subtrees always have their roots as a node that is part of the subtree. So this is one approach. The other approach is subtrees never have. And this fundamentally is it. Because if I always assume that the parents is going to be part of the tree, then I should probably throw an error here and return the function. The node doesn't exist. Because then it means that the parents always has to exist. But then this is the problem, because then I can't use this one. No, but this would start, because this would be, I still think that I can use this one, because then the root would be the node that is a part of the scene. But maybe not, actually. Because it comes down to the pointer again. Because if it is a part of the scene, but it's not the root of the scene, then it can be in the middle of the tree, and then you would have a parent, which means I can't count on this. But if I do them independently, then it's a problem. So I think probably the best way is to pass another... So I have to think about what is the best way to encode the entry points. That's what it comes down to. I do think it's better to make the things separately, because then I don't have to worry about pointers and stuff like that. Like I can just completely separate the subtrees from the main scene tree, and then just think about this stuff later. Because this, like if I get this right and make sure that there isn't any errors at the end, then for any project I don't have to think about it anymore, because the complexity of the projects is going to vary according to the way that I'm going to structure the subtrees. But I need to have a way, obviously, to encode the information of where do I want the subtree to be added to the main tree. Because there are situations where I want to initialize a project on the scene roots with nodes that I create from code, which is probably going to be most often, I think, because it makes more sense to have the layout in the beginning. It should be fully created from code, because it's something that is probably going to be similar regardless of what you do. And even if it isn't similar, it makes sense to create our database of code that has like a range of different starting points that will make it easier to start any project. So it makes sense that it's very likely that the beginning is always going to be through code. But at the same time, it doesn't matter that much, because you also want to have the possibility of starting with code, then adding or changing. So probably the way that it's going to happen most likely, most of the times that makes sense in my mind, is that you initialize with codes, with a layout that you predetermined, that after a bunch of iterations and finding a bunch of layouts, you just select a layout for whatever project you want that you think is good. Then you go with the editor, and then you do adjustments depending on what you. This is another part that is kind of annoying that I was thinking about. Yeah, this is another problem that I'm probably gonna have to encode there, which is that in the way that I'm doing now, the properties that are updated are the ones from code. So this is kind of the issue. So like if you create a node from code and then you change the node state from the editor, then you run the code again, it's gonna revert back to the previous state. Now, obviously, it's not that big of a deal because what you can always do is just change the values on the code to match the ones you put on the editor. So it doesn't matter that much, but obviously it would be better to have a way. But the problem is I'm not really sure. I think it's kind of hard to get this down because I don't know for sure how Godot is going to keep track of the properties. Because there are situations where I had this, where I set a new value on code or I set a new value from the editor, and then the number of properties changes from the two different nodes, the one from the code and the one from the scene, cached on the scene. And so the total number, and this is the reason why I did it like this, is going to depend on where you change the states of the node. So now I'm making so that I'm making based on the lower value. So it just updates, and I'm just setting the nodes that were cached, the state that was cached on the scene to the state that I'm setting from the code. So the code is always the one that has higher priority. Well, I think that the way that I thought about this, actually, yeah, I think that makes more sense, so I don't have to think about this. Yeah, I thought I had this whole chain of thought, then I realized that it doesn't matter that much because what I can always do is just change the... Yeah, I can do a pattern matching based on... which I'm probably gonna do on this function. I think it has to be outside of this function, so I do before this. Yeah, so it's on the add node. Yeah, on the add node function, this function here. I'm going to change this function so that I also pattern match with the prefix, because then that way I know for sure how to differentiate. Because the way that it is now, it doesn't matter what is the pattern for the node name. If the node exists on the scene tree, then it's going to update in the same way. But I can do a check there to see if the node has this prefix. And then if it has that, then I do it the normal code way. And if it doesn't, then I just skip the updating of the properties. Yeah, that's probably what I'm going to do, because then the easiest thing you can do is just, whenever you want the state of a node to be the same after you change from the editor, you just change the name so it doesn't have the prefix. And maybe I can just erase the prefix and keep the same count. So it might fuck up because of the order of the... But I think it doesn't. It's not gonna do that because... Oh, the only thing that matters is the quantity. So like, this is just gonna keep track of how many nodes are added from code, and the order doesn't matter because I'm separating by class type. So even if I switch up stuff, I think it's always gonna be the same. Doesn't matter that much. That's probably what I'm gonna write this down though, so I remember. But the problem is, I think the biggest problem is because the state of the tree created from code depends on the states created from the editor. That's the issue there. And it's very hard to think about a way to manage this, because obviously there's an infinite amount of circumstances. So I'm sure like there are gonna be more problems, I think. And like the biggest problem is that So for example, let's say that I do this and I change the name of the node, then the code is still the same, just gonna change whether or not it updates its properties. But the issue is that if there are other nodes that depend on the properties of the previous node, it's gonna change the logic. That's the problem. But I think that's just an exception. So in those kinds of things, I'm probably gonna have to like make mistakes along the way and see. Because otherwise, and like in the worst scenario, I could just compromise and always change from code to make sure that's. But I guess I can always just change the names again if I want. If I see that there's a problem. So I don't think this is that big of a deal. But if I can think about a way, then probably it's better to like implement as well. I think this way is probably the best and easiest to do. Because it's the easiest way possible to synchronize, I think. You just update the state based on the pattern, the name pattern. And then you just don't change the structure of the tree if the nodes already exist. And so the thing that I have to spend a bunch of time thinking about. So there's two things. One is to how I'm going to do it here with the names. So I'm probably gonna call the function again there. But it's a lot easier to call from here, like I said, because I don't have to think about this too much. So I'm gonna have to change the other function there. Probably not what I'm gonna do. You know? Sure. I deleted the change sync function because I'm not gonna use it anymore. It's not a member. Not sure. So I have to change this here. But the question is where to encode the entry point. Like I want to make it easier as possible there. So like if I do maybe create another class or another struct inside of the class that is gonna be like it has the node and the entry point as a string or string name. And if I put, then I can assign a pattern to determine that is the root. So if I put roots or scene root or whatever, then I just add the node to the root. There's also another problem that I'm not really sure if it's gonna be problematic or not, which is currently I'm keeping track of the names based on the global hash map there, and I use the same one for all the scenes, so this might be problematic as well. But I think it's not gonna be because of what I said, that it doesn't. All that matters is the quantity, because the names are a reflection of the state created by the code. So one option is to create another data structure, and then I synchronize the two based on the hash map. So it is kind of annoying as well to put a hash map that has a vector as the value. It's just more stuff. I think probably the struct is the best way, yeah. That way, then I can keep the vector of nodes instead of the struct. That's probably what I'm gonna do. And it just looks cleaner, I think. So this is probably the way, so there's another struct here. Probably later, but once I finish everything, then it makes more sense, I think, to put like the most functions you can as private. But I don't want to bother with this stuff now. But that's probably what I'm going to do after. So put the variables as private, and then you put setters and getters to access and change the values. But also I think it doesn't change that much because this code here is not going to be, it's not going to be part of the game, because the game builds doesn't, you're probably going to exclude the game, the editor from the game build. So this is more just to build the thing, so it doesn't matter that much thing. So what I'm gonna do here, so I have to think about the name of the struct. I'm gonna create a struct and I'm gonna put the values that I need there. So I think I'm gonna have a hash map that's so maybe I think I'm gonna draw on the schedule there. So I need a way to keep track of the, so each updated route has to have a name that represents the entry points. This part is the, I think doing based on the name is the best way, because the name is less likely to have problems with pointers. So I can always get the name from the scene routes on the entry point of the project. So here, like I would get the name from here, and then I can just stop right away, return the function or whatever if the name doesn't exist on the scene route. So I would update the value here, I think, or maybe before actually. No, but I think it has to be inside of the function, but it doesn't change that much because I can just change the function. Oh, the other thing that I have to think about is the serializer. And I should probably change this as well. So the issue is, obviously, if I'm gonna do multiple different nodes for each sync route, if I want to have the possibility of having, most of the time it's probably only gonna be one because you create only one subtree. But I do think that there are separate situations where after you add nodes from the editor, it makes a lot of sense to create more than one subtree, because then you can compartmentalize the different parts of the scene. But obviously, I always want only one signal serializer for, but I guess I need to pass as an argument, because I'm going to use it to subscribe. So I need to add after all the signals are subscribed. So maybe actually I don't need to add after, because now I was adding after to make sure that the state is updated. But now that I'm updating everything at the end, I think I can just So I could get based on the name there. Not sure if that's the best. So what I'm talking about is like here, I would initialize the serializer here because it's only one for each scene. Then I append to the root right away, and then I get the serializer based on its name. Yeah, but the name is only going to be cached at the end. But I think that one doesn't matter that much, I think. It's more just like, I think I just pass here. I do it the same way that I'm doing here. It doesn't matter that much. This one, so yeah, the only thing that I'm gonna change is this. Like, I should probably just put here, but it doesn't matter. And then I initialize here to make sure that there's always, because if I do more nodes, then I just pass them here to the other functions. But I think that this is just a project by project thing, so there's nothing like to think about. The other stuff is more interesting to think about. So if I'm gonna change a struct, then I would get the values here. So the root value would be the struct there, and then I would get the. So let me think about what I need. So each root of the updated nodes has to have an entry point string name. The entry point string name is either gonna be a predefined pattern to signify that is the root of the scene, or it's gonna be the name of one of the nodes that exists on the tree. So I make the whole logic based on the names, based on the entry point, and then I put a warning if this doesn't have the entry point, because there are gonna be situations where obviously like you change the scene from the editor, and then later on you remove the nodes, and then maybe you forgot some of the code. So it's obviously gonna just, if it doesn't have that entry point, just returns. So this function would change as well. So I'm going to create a struct. Then change the functions. So I have to think, I'm gonna get some water and I'm gonna think about this. I have to think about the name of the struct. So updates maybe. Front structure. Pretty sure if this is the way to initialize there. It's been a long time, yeah. Maybe roots updates. So instead of this one, I'm just gonna pass the values there. I think this is probably better to be updated roots. So I need to think about a different name here. And then here, string name is gonna be so. Oh, but the problem is each one needs to have the thing. So it should be a vector. Maybe create another struct. I could create a struct inside of this struct, or another one outside. Or I can create, I don't think making a hash map is very good, but I'm not really sure. Because essentially this has to be a vector of it has to contain both information, because each root has yeah, each root node has its own entry point. So I should be mapping string name, which is the entry point, the name of the node that is the entry point with the roots, and then it has to be a vector, so mapping of vectors. I could make an array as well. I think so, either a hash, a dictionary, or another class. I'm not really sure if there's other options. So dictionary is better. Dictionary is better if you want to cache, because the variant class supports dictionary. but the purpose of this is not to cache the stuff. It's just to use it on runtime to update. So I think that it doesn't matter. Probably struct is the best one, to be honest. Because then it allows me to put the name there, and it becomes easier to understand what it is. So I'm probably gonna create another struct. I'm just have to debate whether or not to create inside of here or inside of the class. I think probably inside of the class is better. So define the struct outside here, and then I use inside here. That's probably what I'm gonna do. Then I change this here so that it has the type there, and each one of the structure is just gonna contain the entry points. Something like this. So basically like this, I think. So each sync tree has this root updates struct, which has the information for. So there was something else that I wanted to put here, I think. Maybe I can just do the vector directly here. Instead of doing vector. Yeah, I think there was something else that I forgot. So I'm gonna grab what I think that's probably just this. So maybe I can put vector of entry points here. Well, the other thing to think about is the garbage collector, but it's gonna be a lot easier. And the main thing is very confusing because of the pointers. Hmm. So I'm thinking about it now is if you add a subtree, for example, on the main thing. So let's say the parent exists on the tree, but the child doesn't, but the child has children. Then what happens? Like if you add a pointer to the roots, then it's gonna not only add that child, it's gonna add all the other children that the child has. But maybe that doesn't matter that much. So this is kind of the part that is confusing because it is kind of like a black box because I'm not really sure how Godot is gonna perceive. Because I know that there is a difference between the nodes you add as constructors of another node. So if you add nodes as children instead of the constructor of a node, Godot's not going to perceive that them as should be part of the sync file. But maybe it will if you there's something maybe it does perceive them if you set the owner. I don't think I tried to do that. And maybe this issue is that I wasn't. But also, it kind of makes sense to not set the owner. So the reason why it might not be adding them as part of the scene there is because I wasn't setting the owner instead of on the nodes that I add as part of the constructor. But it kind of does make sense to because it makes like it's easier to think about and also gives you the ability to have a node that has a bunch of other nodes as children, but that you don't necessarily want to see them on the editor. So I do think it makes sense to not add, to view them as separately. But I do think that at the states of the game, they are going to be perceived as part of the tree. But it comes like, it's related to what I'm saying now because like how is it going to work with the pointers? That's the question. So if you add the child to the scene tree, then you should automatically add all the children that the child has. So the next time on the iteration where it's recursing there, that is going to add the next child, then I think it's only going to update the properties. It's not going to... So maybe it doesn't matter that much. It's going to update the properties. So I think it doesn't matter that much. It is possible to save a bunch of time if you... And this is the thing that I'm not 100% sure yet, because it is kind of like the... I do think it makes a lot more sense to do this approach now, but it's kind of like the same thing as before. When it comes down to the function that adds the nodes through the scene, is the same logic. But the situation that I'm thinking about is when you have a subtree that you want to add directly to the scene root, then like you're essentially just adding one node, and all the other nodes are going to be updates, but it's kind of pointless to do the updates because you know that they're going to be... But maybe it's not that pointless, actually, because it could be the second time that you are adding. So let me think about So is there something else that I need here? So I'm mapping the name of the scene with a vector of entry points, which are the root node with the name of the node. There's gonna be the where they are inserted on the tree. So I think that's probably, so I'm just gonna do this one, and I'm gonna change the other functions. So this one, how is it going to work? And so I have to change so that it passes both the entry points. So I think I'm probably gonna put a predefined pattern. I don't think I'm gonna set the name. There's gonna be a situation where, yeah, so I probably in the beginning of all the functions, I'm gonna make the tree independent of the. And so probably on the layout functions, I'm not gonna receive the scene root because it doesn't matter. So like on functions where you're gonna create the state of the scene, starting directly from code, then it doesn't matter. You don't need to have the scene root. You can create the subtree like completely independent. And obviously, it's better if you want like later on to also add new nodes. But maybe not actually. Maybe not. Maybe it does make sense, sure. So because what I'm thinking about, I was thinking like, let's say you want to create the initial layout entirely from code, and then you want to add another node from the editor, and then add more stuff to that node. It doesn't make sense to change the original functions to take into account that new node, because obviously you can create another subtree that starts off from that node. That way you compartmentalize the functionality. So in that case, the layout functions, for example, would always create their own subtrees, and then they can set the endpoints, or just keep them separately. So layouts are just functions that create functions that create subtrees that return the roots of the subtree. Then from outside, I determine the entry points, which is going to be the roots of the scene. So entry points, I could have a predefined pattern for the roots. I need to have a predefined pattern, so, or I can just use empty string, but it feels like kind of bad to use empty string because there can be other situations where something like that might happen, where you have a empty string. So I think it's better to choose a predefined pattern to have maybe roots node. That should be something that I'm probably use in the actual scenes. So like something that is exclusive. So maybe just do the prefix should be root node. So maybe like this. Root nodes. Or maybe just roots. It's easier to remember. So I'm gonna make the functions based on the pattern. It's gonna receive the entry points. Sync path. So now let me think. Yeah, so the sync path is the same stuff. And here it creates an entry points. Let me think about this. I guess it doesn't matter, you always create a new one. And this might be problematic because of where I'm creating, because I'm not allocating memory, so. But I'm gonna task like this. No. So I have to change. So here I probably, in this case, specifically, I'm just gonna send the need sequence. Because I'm like, this is the pattern I'm gonna choose to determine that on the function there. I'm trying to find whether or not this is a good idea. Sure. Because it feels kind of it's an additional thing you have to remember each time, but I don't think there's a better way. It's testing for empty string seems kind of bad. So I think I just have to do this pattern. So whenever I pass this pattern, we're gonna change the function that updates the main tree to check for this pattern if the name on the entry point is this pattern. And if it is, then it means that the first node is going to be added to the sing root. And if it isn't, then I have to think about. If it isn't, I just check normally, so I just call the other function. Because then is apparent that is a part of the sing root. So let me think about this. No, if it isn't, I just add to, I just find, try to find the node that it has that name on the tree. If it doesn't exist, then I just throw an error. Yeah. So I'm gonna change these functions here, so that's me. If I have to remove this, well. I think I don't remove this. It's initialize there because I'm gonna need. But I do remove the. Let me think about this. So maybe actually I can also just, so if I do like this, then I can, but then I still need the serializer. I'm thinking about what is the best way to use the same signal serializer for all the updated routes. Because the problem is I need access to the serializer, so I can't add directly to the scene routes. Because obviously if I want to cache the signals, it's going to be based on the serializer. So I think it makes sense if I pass the serializer as an argument to all the functions. Then what is the best way to create or to add to the, because I don't want, I think that this can be problematic, that's the problem. So the way that I'm thinking about now is just removing the scene root here, because then I make the functions, like if I'm adding directly to the, if I'm adding directly to the scene root, then I don't need to specify the scene root here. It's only when I'm gonna add a subtree in a specific parts on the main scene that I need the scene root, because then the logic's gonna be based on finding the node. But even in those situations, I can do it outside of the function as well. But I would need to pass the, either I would need to pass the scene root or the entry point node, I think. Maybe not actually, because I can just do the, yeah, I can do the logic outside actually. So I can completely separate the logics for creating the subtrees from the scene updates, because I can put all the logic for the entry points outside based on the function here, which makes a lot more sense. So like the size of the vector of the updates is going to be directly correlated with how many entry points I want, how many, the variance of the entry points from the nodes from code. And then like each subtree that I create is like its own island that the state is reflected on code based on the name. This kind of, because then there's also the problem there that if I want to update from the editor, and if I change the name to that, then it's gonna fuck up the, it might fuck up a subtree. Yeah, I have to think more about this. So I'm thinking about a situation where I have a subtree that's gonna be like the way that I'm creating here, but then at the end, like let's say I create subtree and then I want to change the state of the node by changing its name so that it's not updated through the code. Then it becomes a problem because next time they run the code, it's gonna add an extra node because it's not gonna be aware that so the challenge is, so I might have to think about like, or to encode some extra logic on the update function that determines whether or not I want the node to be updated, which I wanted to avoid doing. Yeah, but I guess I'll think about this later, so it's probably better to focus on the other stuff. Mm. Yeah, I think so. Doing like this is probably better. So I never expose the scene root in the thing here. Or do I? I do expose. Yeah, I need to expose. But I only use on the situations where I want to. Because then, like, I'm essentially going to be exposing to check to see if the node exists on the tree whenever I want. But I remove from here. Then how do I do this? I was thinking about putting in. I think the easiest way is just to put here as well. Then I just add at the end. It doesn't matter that much. Obviously, I'm gonna pass this at some point as well. Just gonna remove that. And then I remove from here. Because it doesn't make sense to... It makes sense to add the serializer at the end. So that it updates based on the... Maybe I always add before though. So the serializer is the first node that I add. So because this is gonna... Yeah, I'm obviously for each subtree that I create, I'm just putting there on the vector. So this means that I should probably put before actually. No, but the problem is that, well, actually it does make sense. So I put it here outside of the scenes. Oh no, but for each scene I need its own serializer. So it does make sense to put here, I think. Each scene has its own serializer. So, but at the beginning of each scene, I put them here, and then yeah, I think that's probably fine. So... just making sure, I probably should remove that. Which one is it? Right there. I'm probably gonna move this function to the layouts as well, after I make sure that it works. So this one is not going to receive. So once if I maybe to make this work, then instead of putting the function here, I'm just going to put on the layouts, and then I'm just going to like develop a bunch, or like do a bunch of iterations to get or create different layouts functions to use as entry points, and then for each project I just include obviously, or just do the files and call the function directly. So it's just a function that receives the signal serializer. Oh, it doesn't need to receive, that's the question. I guess it does, yeah. So receive the signal serializer to cache if there are connections on the layout. Because I'm not going to be adding the serializer, I'm just going to be using it to cache the connection. And then for each one that I create here, maybe it does make sense. So for each subtree that I create, I just push here based on the whatever entry point I want. So if I want to create a subtree that is going to be somewhere along the middle of the main scene, I call find child based on the scene roots to see if the child exists, and then if it does, I get the name and then I pass the name here. after calling the function to get the node. I think for this one, it's probably... And here I remove the signal. I think from here it's probably... Now the challenge is going to be on the last function there to think about how to structure things. So the root, the key is name of the scene. So I'm going to find on the other dictionary. Doesn't exist, continue. Exists, I get the scene. The root node of the scene from the other dictionary, from the other hash map. I'm gonna comment this out for now. I'm not gonna use. And initialize the signal serializer, which as the first vector there's gonna be appended to the root at the end, and then create the layout in the signal serializer. Then I push the, there's going to have 2 endpoints on the vector. If it makes sense, I think this way is probably better. So it doesn't make sense to push here directly because it makes more sense to create the endpoint instead of the function that is part of the HTML menu. I think it's easier to think about. We're gonna try to do this. Let's replace. Now let me, if I forgot something, then it's gonna complain. File. So I have to think about. So this is one of the main functions, the other one. So I guess. So I'm gonna change the, I'm gonna put another argument here. This one. Now let me spend. So I think I'm looping over the nodes, the scenes from the update roots. The root value is gonna be, maybe I should do like the same way that I did on the other one. Because it makes it easier to understand. Okay, now. So if it doesn't have entry points, it means that there are no updates or the thing. So just continue. If the project doesn't have, the project roots doesn't have the sync path, it means that something went wrong when extracting. It's probably never gonna happen because I'm initializing them in the same place. So maybe it's unnecessary to put this here, but I think it doesn't matter that much. Then against the sync roots from the project's roots using the sync path. And then I loop over the entry points. So yeah, this instead of being this is gonna be entry points. So which name I can put here? I think it should be like this. Or maybe just entry points. So inside of here, I'm going to get the path. So I think it. So it probably makes more sense to let's just search for the entry points here, maybe. I think I do have to. I have to change the other one, so because the logic on the other one is going to depend on the. Like I have to send something because this part's going to depend, I think. So if it doesn't have, since I'm going to do it completely separate, I can guarantee that the parent is always going to have no pointer in the first iteration, because the first node that I pass here is going to be the root of the subtree. So because they are separate trees, the root of the subtree doesn't have a parent. There's going to be no pointer in the beginning. Which means it's going to go here. So this part is the one that I have to check. I think it doesn't matter because I have to pass anyway. Either I pass a node or a string name, so I think it doesn't matter. So I have to change this function. I'm obviously never going to change the. So maybe I make it as the third argument, and then based on the entry points. So I try to find. So I basically find the node based on the entry points and then add as a child of that. So the other ones don't matter because as long as the parents is part of the tree, the rest of the logic I think works. Because then after the first iteration is gonna always go here. So this is like the first node that gets added. So here I have to check. So I probably should. So this is what I was gonna do. So instead of doing this, because initially I thought that I could just do the logic here, but not now that I remember about the names, I think it does make sense to call the other function. So I'm probably gonna have to, because here I'm thinking that I have to check if this exists or not. If it doesn't exist, actually, I should just throw an error. Just check, see, because if the entry point doesn't exist, then I should probably throw an error and return. Question is it gonna fuck up everything? I think it just is gonna stop. It's not gonna recurse if I return, because it has to come here. But maybe like I should assume that there's an edge case that it will. So what's gonna happen if it recurses? So let's say for whatever reason the first node has, and it's supposed to be. No, the parents no. I think that this is probably guaranteed. So it's always gonna hit this branch whenever is the first node. So it's the root of the subtree. So I think I can guarantee that. Yeah, but let's. Yeah, because there isn't a situation where it's possible for that to not be the case. Let's say I pass a node that is not the root of the subtree. Then what happens? Then it falls here. So I need to have a way to deal with this, I think. But I think that if the node's already part of the parent doesn't. So maybe on this one I check to see. Here I think I have to make sure that the parents exist on the tree. That's the condition. So as long as I make sure that the parents, I check to see. So the parent always has to exist on the tree, on this branch, because it always has to go here in the beginning. So if it doesn't, the parent doesn't exist, it's because something went wrong. Yeah, but maybe because of this stack, the way that this is gonna work, when this is running, is gonna mess up. Alright, I guess I will see. So I'm gonna try to do it like this first, and maybe I'll get errors. Then I'll figure out. Because the black box that I don't know is that, like, the logic that I'm assuming is that you call this function, so this is gonna be the root. Then it adds the root to the whatever entry points the scene has. Then on the next iteration, when it calls this recursively here, so it's getting the child and then it's looping over the children of the root node, and then it's calling the function recursively. So on the next iteration that is going to call this, it's going to be the child. So the child obviously is going to have the parent. So it's going to always hit here. So that means that the parent should always exist on the scene tree because it was added here. But then the issue is I'm not really sure how it's going to work with the add child here. So I'm not really sure if automatically it's going to change. I think it will, based on the function, the way that it works. But there might be some weird situations, like on the menu bar, for example, that the logic of the class depends on what happened when you added the child. But I think it's always going to have, probably. So I could ask ChatGPT as well. But I do think that it's always going to have the nodes. I'll put this warning. It's not. So I think here is guaranteed to always return. Maybe. So if the entry point's name is not the root, then it hits here. So let me think about a situation where that's not going to be the case. So if the node doesn't have a parent, then it has to mean that it is the root. I can think about a case where that's not what happens. So I think it is always guaranteed to hit here when it is the root. Which means that it has to be true that this node exists on the tree, otherwise. So if the only exception is whenever you are adding the subtree directly to the roots, which is this one. So there can be a situation where I put the wrong name for whatever reason. So I mean to put this pattern, but I don't. So it hits here and doesn't find on the tree. And then it returns. But I think on that situation, it's always guaranteed to... Yeah, but I wonder if this is a problem. But I think it isn't, because it's just going to return the function. It's not going to call recursively. So I think it is always guaranteed to hit here and should not recurse. And then if it doesn't, then it means that this exists, so it adds the thing directly on the entry point. So this will happen if I put the name by accident on a different pattern for the roots node. Also, the thing that I should do here is use the... I should set the name of this. Set the name of the node. So I'm contemplating whether or not it's better to call the function always. I think it probably is, actually, to be honest. And I'm probably gonna have to change the other function. So I have to think about this function now. Because on this one, I was thinking about... It's gonna get to the... I think I need to pass the name. I need to pass the name because I need to find the node inside of the function. Or maybe not. Yeah, but actually I do need to pass. So if I guarantee the parent is always inside of the sing root, then I can get the node from outside. And then it solves the problem with the pointer because I don't need to have... Because the tree is already built, I don't need to have the node outside of the function the moment I call this setChild node, so it removes the problem of having to update the pointer here. So I think I can leave the function like this and always pass the parents. The parent's gonna be so sing parent. Maybe I should change the name so that it makes more sense. So if I always guarantee that the parent exists on the sing. Yeah, I should probably do that. So I always guarantee the parent is on the scene. So I'm gonna think about this later. So I'm gonna finish thinking about this. So I'm gonna try to make it like this, where, so the reason why I want to call the function is because it's just easier to update the global variable that is gonna keep track of the names. So every time that I add a node, I have to update, either make it as 0 or update the value of the hash map that keeps track of the names. And also set the name of the node should be that. So I do think it makes sense, should probably. And I should probably do the same on the other. Yeah, but this is the problem, so I think here I have to set it outside though. On the root node. So, but if I always guarantee that the parents is part of the tree, then maybe I can simplify the other function as well. And maybe I do this stuff on the other function, where I look for the nodes on the scene roots. It's kind of hard to think about. Because I need both the parents and the child. So I'm thinking about whether or not to, like, the problem here, I guess I can change, I just changed the function there. I was gonna say the problem is on the other function. Hmm. I don't think it makes sense. Like, I was gonna say that I should pass this pattern to this function here, change the function, so I include this pattern somehow. But I think it doesn't make sense. Because the thing that, so it probably is easier to just update the value here as well, like outside here, which is not very good. So maybe there's another way to do this. Because the issue with calling the function there is because of the whole thing about when the first node is the parents, then it becomes hard to think about the logic inside of the function there. Because when the first node is the scene root, the scene root's not gonna have a name, and it's not supposed to have the name of the pattern that I'm using to differentiate nodes created from code than nodes created from the editor. So I don't want to make, like, so there's two different options. When you set the name of the root, the scene root with always a pattern. So it could be this, like I could always set the name of the scene root to have this name, and then change the logic inside of the function so that it takes that into account. Or I can check to see if it's an empty string, and then I always assume that the scene root is an empty string, and then differentiate inside of this function based on this. But I'm not really sure if either of these approaches is very good. I think it's probably better if I can do it, like, separate the logic and put it outside, and then just leave the function to always work in the same way. So this function is the most confusing one, because there's so many scenarios, it's hard to think about. But my guts tells me that there's probably a better way, because this is not very good to, like, it's better if I always increase outside. So obviously I can just leave the roots of the subtrees to not have a name, but that's not very good. So the thing that I'm thinking, like, I can't add directly here because I have to update the name here. And in order to update the name, I need to call the function there. It's kind of confusing because of the order you have to increment, and you have to check just say. I can't think about a way to do this. No. The only way that I can think about is this. So just doing the same thing and then adding directly. So I can separate the... This would be update now. This is the only way you can think about this. Then would be updates now. I think you have to set after you add. When you add a child normally, you set the property after, I think. But maybe it probably doesn't matter that much. You can test both ways. But I have to set. So the thing that I don't like is this, like having to do this update here inside of this function. Because in my mind, it increases the chance that I'm going to make a mistake. So it's obviously better if you always update the value in the same place of this thing. But then it gets into the problem of having to change the structure of this function here. Which is not very good. Because it all comes down to the sing roots. Because I can't pass sing roots as a parent. Because on the logic of this function, I think I have to check. So this is the thing that I was going to think about. So maybe now it's better to spend time thinking about the structure of this function here. So I'm going to change both of this. Because here I realize that like, in order to get the names of the nodes, I need to call the other function. Because the other function is going to do this check here. It's going to check on the hash set, the nodes exists. Or actually, it's going to create a pattern based on based on the node gets the class, and then it gets the value of the thing based on the hash map. So it creates the name of the pattern. Oh, but I guess I can call this pattern here as well. Yeah, but then it defeats the point. So it's easier to just call the function there. And then do the updates inside of the function. So instead of getting the node name here and the parent name here, and so I probably should pass the sing root to the other function. I think it makes more sense. Because inside of the other function, what I'm going to do is just search for the... So I'm always going to assume that the parents has to exist on the sing roots. And then I'm going to make the logic based on that instead of the add child node function. And this is the function that I was talking about. So I guess like this is the biggest thing that I'm not really sure. I guess if I call this one. But if the parent exists on the root, then I don't need to duplicate. So also like the tricky part is figuring out if this is gonna be, if the next, when you recurse the function, if the node is already going to be on the tree, because it added here, which I think it will, but I'm not 100% sure. So it all comes down to this, because the first node has to be on the tree. The first parent. And from that point, the parents are always going to exist. So I'm going to remove this stuff. And I'm going to comment this one out because I might use on the other one, the duplicates. But what I'm thinking about is I use the scene. This is what I said. And maybe it's better to just pass the name. And so instead of passing the node, I pass the name. And then here, it would be better if I get the name from the entry point node. So I think on this one, I'm probably gonna put like the string name for the pattern or for the parent's name. So it's gonna receive the scene roots, the parent's name, and the child. And then I always assume that the parent's part of the tree, and then I make sure to check on the inside of this function, because I think that makes sense. And then inside of the function, then I get the parents, I get the node based on the name that I passed there. So remove this. And then if I always assume that the node is part of the scene tree, then I don't need to worry about the pointers. I think this is the point that I was getting at. Because on the other one, the way that I was doing this is that I'm receiving the nodes, and then I'm adding the child to the nodes that comes from outside the function. And this was the thing that was very confusing and is causing a lot of problems, because the logic outside depends on the pointers here, and also on the exchange here, which is not very good. So this is the reason why I did this code here, but I was getting other errors, so I'm gonna have to see if this works. But what I'm thinking about now is I receive the string name here for the parents, and then I just use the root to find the node here. And then I check. The only place where this is problematic is the roots. But if I handle the root outside on the other function, then it should probably work, I think. So if I get the node pointer from the name, then I'm getting the node that is already on the scene, which means it's a lot easier. So this situation would be a case where the child is not on the scene, but the parent is. And then I get the roots. So I'm gonna do that. I think this makes sense. So I just change parent's name. Then I put here. So now let me think about this. So here I do. So I think it is better if I get the nodes, the name from this, because then it makes sure that it is the name of the node that is on the actual scene tree. So I find the entry points based on the scene roots. In this case is the first when I'm adding directly on the scene roots. So this case is when I'm adding the subtree to a node that's parts of the scene. It's not the roots. It just returns. Yes, I think this is fine. And this is a case where I'm adding a new child and the parent exists. So this is a child of the updated tree, the subtree. So here I just get the name. And then I pass the updated. So now let me change the other stuff. Updated. Point. So sure. Entry point name never changes. And then here, date right now. Which one's now? So let me see. So now let me think about this function here. So this function receives the root, the parent name, and the child's. Just the node is going to be updated. I'll add child nodes. So here I get the only thing that I'm gonna think about after is this stuff here. So if I make this work on this function here, I fix this one. Then I'm gonna think about if there's a way to put the counts as well there. Or just create a function to make it easier. Yeah, well, let me. So this one receives guess the class name, the type of the name of the type of the class here. And I check to see if already exists. If it doesn't, initialize a 0. Then get the pattern of the node name based on the child. I'm gonna change this so it's easier to differentiate or to see. Also, I think I'm going to just because I was thinking about a situation where like the hash set's probably gonna have an empty string because probably the root of the things is always an empty string with the name. So this is the reason why I put here condition. But I'm gonna remove now, and I'm just gonna let the annoying warning there because it's better. So the thing that I have to, I'm gonna delete this. So let me walk through the thing. The name, check to see if it is already on the hash sets. So that means that the node exists on the tree. So if the node exists on the tree, I just get from here, and for whatever reason, I check here to see if that's still true. So if this condition hits, something weird going on. It's probably never gonna hit because I'm updating the hash sets after I got the sing roots. So yeah, just to prevent like precaution. But I think that's, so I was gonna hit this. So this is the tree, this is the node that already exists on the tree, that is supposed to be this one. So I got the type. This one also, I'm not really sure if this is necessary to check if they have the same type, but it's whatever. So this one receives the two different nodes and updates their properties. And then here I'm resetting the name to be this name and the owner, so that because here is gonna clean it up. I guess I can change the functionality here as well, but I think this way is probably good enough. So I just set whatever properties on the tree nodes with the one from the code. Oh, this part's another one. So here I'm going to comment this out, remove this. Because now I'm gonna clean all the nodes on the same place, I think. So at the end there, on the destructor of the HTTP manager, I'm just gonna loop over. I'm gonna do the same way that I was cleaning up the project roots. I'm gonna clean up the updated roots. So I'm just gonna clean them on the same place. The confusing parts is the pointers, but I'm gonna see this later. The other thing to think about is this stuff of the order in which you update nodes. So if I do the thing where I change the... Yeah, so I should probably have... Oh, but it's not gonna... The problem is that it doesn't matter. This is not very good. Actually, it doesn't matter. Yeah, now that I'm thinking about is like the name that I get here is always going to be from a node that was created from code, because I'm only calling this function passing children that come from the updated roots, which is created on code. So if I change the name of nodes, yeah, but I still have the same problem actually. Because if I create the subtree from code and then later on the editor I change one of the nodes that were created from the code, I change the name so that the node's not updated through code anymore, it's gonna create a new... But is it or not? I think it is. It is gonna, because then it's not gonna have the node on the tree anymore. So I need to think about a way to... So either I encode the information outside, or I need to think about a way to change this function here so that it doesn't matter which one so I can decide which one I want to update. Because if I change a node from the editor that I created from code, I want to have the possibility to not re-update its states from the code. So I'm gonna write this down so I think about this later. That's basically... So this part I think is fine this way. So it's always gonna update for now with the latest state from the code if the node already exists on the tree. So if it doesn't, then it's a new node, then the parent has to exist. So I remove. So I'm receiving the parent's name and I look for it's on the tree. So if this is true, then it means that it does exist, and then I just add the child to the... And then this is the place where I was trying to swap as well. And if it doesn't exist, then I just send the warning message. Because the parent should always exist on the tree. Yeah, so I think this is fine. Outside of the other stuff that I'm thinking about, I think this should probably work. Oh, I need to set the name. I forgot the name. So here... Yeah. So maybe I should do this... I should do this here, actually. As I'm setting... So maybe I should change here, actually. So because on this one, I put the condition there to not update the... I'm gonna test like this, actually. I'm just gonna leave it like this for now. I'm gonna remove this name here. Because when I wasn't putting this, it was setting the name of the node to an empty string. But I think if I always sat there before, and it does make more sense to set the name here. Because regardless of which way it goes, the node should have the same name. And then I don't set here. I don't set here. The only thing is, I'm not really sure if you need to set after you add as a child, or if you set before. I think it doesn't matter. Like, I don't see any reason why it would matter. because you're just setting the value on the pointer. So when you add there, it's gonna be the same pointer. So I think that this should work probably. There's probably a lot of stuff that I missed. And there's also the other stuff that I have to think about, but I think I'm gonna try to compile and see what happens. Experience. So if that is the roots, there's probably stuff outside that I forgot. So this part is the one that I have to think about as well. So like, how can I find a better way to do this here? So when adding the first node, how can I increment the counts? So I'll be right back. Actually, I think I'm gonna stop streaming here, and then I'm just gonna, because the timer ran out that I had for this. So I'm just gonna think more about this on off stream. So like the biggest questions I have are related to whether or not the pointers are gonna be correct, and about these nuances of the branches here, like what's gonna happen, like if there's some edge cases or something like that that might fuck up everything. So I have to probably do this. When you're using side of the function, you don't need. $57. So did I change there? So maybe I'm not passing the correct thing. Not sure why this happened. I'm gonna try to. I'll be right back, and then I'm gonna try to spend some time fixing these errors. So I'll be right back. So I'm probably not gonna stay for a long time. Yeah. So what else? So I'm gonna have to change, I think. Maybe I should specify HTTP manager. I think probably I should specify that. Oh, this. Oh. Maybe it's this. But maybe I have to specify that it's coming from this class. I'm not really sure. Because there's a templated on the vector, so the vector is outside of the class. But I'm not really sure if it's necessary or not. Maybe it's just the typo. It's probably. Oh. Center points. Senior roots, later roots. It's because of the way that I was doing before. Your points. Fire. So HT manager. Blah blah blah. Oh, I have to put here probably as well as one complaint, I think. Yeah. Oh fuck. I should probably comment this out. So now, I think I do need, before I run, well, maybe I should run just to see what happens. But I do need to take a break to think about, because there's so many different things to think about that can be potentially wrong, or maybe it's right, but it's not the, like for example, the thing about the properties there of being able to update from the editor after I set up from code. So it's gonna be hard to, I need to take a break to clarify my mind and then come back and then run and see what happens. But I'm gonna run to see if there's an error there, or there are errors. This was the after the last time that I added, so yeah. So there is something wrong here. I think that it was the same. It was a similar error that I was getting, which was the reason why it made me think to change everything. So, like the most confusing thing is about the pointers there, that kind of stuff. So I'm putting the name here. This is the thing that is weird. I guess it's because of the. So one of the things that was weird was the name. The time that I add here. I remember that. Yeah, so it's probably because of this here. So what is happening is that it has one thing. Like the thing there is not correct. The count here. So it's supposed to be 0, but it's 1. So the count is the problem. Because I'm, but it's kind of weird. Oh, it's because I didn't set. No, but I do think I put HD roots here. Oh, it's what happens when I put. But the order should be the only thing that matters, I think. Yeah, this is weird. I'm pretty sure, almost 100% sure, that the error is that I'm incrementing the counts, and when I call the add child node next time, like I'm passing the wrong name. I think that's what's happening. The HT panel here should be 0, the first. So I think the problem is here. The question is, why would that be the case? Because if you follow here, it seems correct. I guess the name from the node here, which should be 0 in the first place, because of this. Then I'm adding to the scene routes, I'm updating them there. And then I increase. Oh, but yeah, so next time that it checks to But the parent name should come from the... But I think it's off because next time that it checks is gonna be... But that's... Like, it should be 1 here next time. Like, this name here in the first one should be the same name here, I think. Let's get in the parents. So it should exist here. Unless I'm using this somewhere else and I forgot. I'm pretty sure not. No. I was going twice there. So the first time that it calls here is going to be for the signal serializer. So it's not going to have a parent, it's going to call here, it's going to have here. But it should be dependent on the name of the class, so it shouldn't change anything. So the only thing that makes sense is this, but I have to set the name, or is the thing that I was talking about before as well. That's because I'm not 100% sure, like based on the execution of the function, if the next time that it calls the function recursively, if the node's already gonna be on this thing, yeah. Well, this is a problem. But I do think it's something related to the names because of the first node here. It should be 0 and 1. I'm pretty sure. Yeah, here is 0. So I do think it's something to do with the name. It's not because it's not adding. It's adding the incorrect thing. Oh, maybe it's because it's calling here. But I'm pretty sure it's the same. Maybe I can go with the debugger. It's gonna be easier to understand. So another thing that would be interesting, maybe if I don't increase here. So 0, 0. Yeah, but it wouldn't make sense because it has at this point it has to be. No, the parents is gonna be the 0. It's gonna hit here. Let me, I'm just gonna, so I'm gonna test this one thing, then I'm gonna stop streaming, which is just gonna be to not add here. And then I'm gonna see if I can, I'm gonna take a break and see if I can figure out, I'm gonna probably go over with the debugger. Just see. But even if this does work, it doesn't seem like, it doesn't feel right to do here. So I have to think about to always update, to structure in a way that I always update in the same place. But then it becomes a problem because I don't want to call the function there. Oh, but now that I'm passing the name, I can just put the logic inside of the function. Yeah, that's what I'm gonna do. So I just call the function and I'm gonna test to see. But I'm gonna do that. So here, instead of updating there, I'm going to just pass point name. It might be something else as well. Point name. Let's think about this. Yeah, so just there might be a better way to do this, but just want to see if it works. I'm already setting the name here. Oh, it might be because I changed here. Because I deleted the string name here. Or maybe it might be better. So I'm gonna think about this later as well, but I might revert back to this way here. Because then, like, I don't have, it just simplifies everything. And then I just set the name on the two different places. So set here again. This is the issue because here, yeah, I think it is a problem. So I'm gonna do that now as well. Because I'm setting the name of the child and I'm not setting the name of the tree node. So he's gonna, yeah, but he should update with the same name. But I think I'm just gonna, in order to make it easier, I'm just gonna revert back to the other approach. So set here. Let me put here. Just it here. So if it's not roots and it has the thing, then goes here. So if it's HD roots is gonna be the roots of the thing, so I add the child directly to the roots. Because I'm appending the root of the subtree directly to the string roots. So the thing about the pointers is that after this point, all the other nodes should be part of the tree, so it's always gonna hit here, I think. Because it's also adding all the children, I think. But actually not, because the hash set's based on the scene, not the... Yeah, so I do think it's gonna go here as well. On the first time. On the first time that it runs, it always goes here, and then the second time that it runs, because it cached everything on the scene, is always gonna go here, I think. Well, let me see. So if the name is equal, then add directly. So here should be else, probably. Maybe I put else if here, and then I put the conditioner. Yeah, should be correct. So if it is roots, I just add directly, start the name. And if it isn't, then it means that the parents is child, so I get from the same roots. Then I add here, and the child should the tree nodes. And then set the name. So it should be correct. If it doesn't work, then I'm gonna have to, probably gonna go over with the debugger and spend a bunch of time thinking about what is going on. It's probably the difficult situations is when, but now it should change because I'm doing everything on the same time. But it might be because of the recursion there, I think. The way that it's gonna work here. Yeah, so there's something else. So now the name is messed up. Oh, it's because the parents. I'm not inserting the parents. This is the problem. Yeah, this is the issue. I forgot about this. So yeah, the whole thing, the whole reason why I was passing the node is because I need to get the name. No, the parent node should be from the tree. It's also weird that here is 1 as well. It shouldn't be 1. So I think I'm gonna have to go with the debugger. But it's something going on here on this branch, I think. So I'm passing... because the problem is the first node. That's the... Because the parent's name... Like before, the way that I was doing, every node would have the name here. But I should be setting the name here. But what is the child there? And the child should be the... On this situation, the child should be the root of the thing. Or the subtree, the root of the subtree. So the root of the subtree should be the thing that has the name. This is the thing that is kind of confusing. Let's say it's not hitting here. I think it's a situation where it doesn't hit this thing. But then you would throw the error message here. But maybe this is the root of this thing. But then it wouldn't, yeah. I think that doesn't make sense. It's probably going here. I'm gonna stop streaming. I'm gonna take a break and then I'm gonna go over with the debugger. But I assume that it's probably because of this condition here. So what I'm thinking about, if it is something related to the way that I'm setting up the parent's name, then I can change this function here, or the other one to update the parent names as well, based on the hash sets. Or check if the parents... Yeah, something along those lines. But I'm pretty sure, I think that the reason why is something related to the way that the set name is working here. Or maybe it's because I'm not setting the owner. Could be because of the owner. This might complain that the hash should be part of the sync tree. About... Okay, so this is the last thing that I'm gonna try. It might be because of the owner. But if it is, then there's something weird going on as well. I think it's something else related to the names. Interesting. Well, it's because of the pointer, I think. Because I'm passing the pointer that is part of the other thing. So I should probably... So I'm gonna try to use the duplicate thing. So this is the last thing that I'm gonna try. Yeah, so this is the issue. It is what I was concerned about as well. Because the problem is I'm not pretty sure, even if you duplicate, if it's gonna have the same children. So obviously I can look into the function there. But if it doesn't, have to think about how I'm going to do this. I guess like I'm just gonna have to call remove child. But then it gets very complicated and very confusing. So there might be an easier way to do this. Because I'm pretty sure that this is gonna... I don't see why you wouldn't put the children as well. So it's gonna complain about the same thing, I think. Yeah. So the challenge is to figure out... I'm creating the bridge of the state based on the name logic. So like the recursive function that traverses the tree is like the flow from one tree to the other that synchronizes both. And I need to figure out how to... Because if I start from the top, it's very... maybe if I remove the child... But I'm not really sure if it's very good. So like if you remove the child here for the roots and then you add to the other one. So you remove the node from the previous tree and then you add. But then it's really bad because then it fucks that up here, I think. But maybe not actually, because you wouldn't change. It would be like you're removing the roots nodes. But that doesn't make sense. Like for each node you need to remove, but then the problem is because you're starting from the top, it's gonna put all the other children that that node has on the other tree, on the scene tree. Which would work, I think, if I find a way to make this happen, because on the next iterations is never gonna hit the other branch again, because the scene tree already is already gonna have all the nodes, but maybe not because of the hash settler, and so it would be a problem as well. So I need to figure out what is the best way to remove nodes of one tree and then put them on the other, or to create a copy without carrying away the children. So like I would initialize a new node, and then copy the properties of the other one, but I'm not really sure if that's good as well. So I have to think about a strategy here, and I'm probably gonna ask ChatGPT as well. But the issue here is probably because when you add this child to this one is a pointer, so it's gonna have all the children as well, and it's attached to the other tree. So I need to figure out a way to move node by node from one tree to the other. That's basically what it comes down to, I think. So once I make that happen, then I think it's probably gonna work, I think. But I'm gonna stop here. So next time I'm gonna continue to develop this stuff here. So see you then.